Okay, we're going to solve this problem for both energy, the first step, solve for energy, H times V. And then once we know energy, we can put that in the middle and solve for wavelength, that upside down Y on the right-hand side. So it's two steps. First thing we're going to do is solve energy. And we're told that the frequency is 94.9. Well, actually, we're told it's 94.9 megahertz, right? But when you see a megahertz, 94.9 megahertz, when you see M, what do? Capital M means million. Just think million. Capital M is million, which is the same as 10 to the sixth, okay? Get rid of the M. First thing you do when you see a capital M, get rid of the M and write 10 to the sixth. That's a million. So now I've got 94.9 times 10 to the sixth. And I like to write in scientific notation, meaning the decimal has to be after the first number, not after the second number. Here it's after the 4. So I got rid of the M. Million is 10 to the sixth. Now I'm going to move the decimal one place to the left. And then that'll change the exponent up or down. Will that become 10 to the seventh or 10 to the fifth? Well, when I make this 9.49, I have to add 1 to the exponent. There we go. So 94.9 megahertz is 9.49 times 10 to the 7th hertz. So you can pause the video, make sure you understand that. Make sure you got that. You can pause the video. All right. So now we have V, frequency V, and we need just to multiply times H, blue H. I like to draw Planck's constant in blue, to get energy. Energy equals that. And I'll write energy in red. Okay. All right. So we're ready to type the numbers in the calculator, but we have to do it carefully. Okay. Let me show you what I mean. So we've got the frequency here. And we're just multiplying it times Planck's constant, 6.626 times 10 to the 34, right? Seems simple enough. Stop right there. Do not put this in your calculator. You're going to probably make a mistake. I don't know why they don't teach this. It took me years to figure out. Much, much easier. Reorganize the exponents. Put the exponents right next to each other. Don't leave him here. Don't leave him here. Put the base 10 with the exponents right next to each other. Do that first. So times 10 to the what? It's minus 34 plus 7, right? I put them next to each other and I just add the exponents, right? You got a minus 34 here in blue, and you got a plus 7 in black. I'll make this one blue also. So do not type in your calculator yet. You're just rewriting the numbers. And put the exponents next to each other. I can't stress how important that is. The base 10 with the exponents, and just add the exponents when you're multiplying. So 10 to the minus 34 times 10 to the 7th, just go to the right, times 10 to the minus 34 plus 7, which we know is minus 27. So I haven't used my calculator yet. Okay? Don't do your calculator yet. Then I put right next to each other the decimal numbers. I got a 6.626 and I got a 9.49. With the multiplication, I put those right next to each other. Okay? Now I can type in my calculator. I don't have to worry about the exponent. Do not type an exponent in your calculator. You're going to probably make a mistake. At least I do. So just do 6.626 times 9.49 in your calculator. Nothing else. What are those two numbers? 6.626 times 9.49. What do you get? Oh, wait. What do you get? Type it in. Hopefully you get 62.88. Right? You get 62.88, but it's times 10 to the minus 20. I'll just get what you get with the calculator. 62.88, and that's still minus 27. Right? I didn't change this guy here. I'll leave that black. I'll leave the exponent part black. That's better. Okay. All right. So I get. Don't even type this in your calculator. Just leave it. Leave the base 10 to the minus 27 alone. You got 62.88, but in scientific notation, you have to move the decimal where? You don't want to leave it 62. You want to leave it 6.2. So cut it out there and put it here, and then add 1. So minus 27 to the exponent. Add 1 to the exponent. So minus 27 plus 1 is minus 26. That's our energy. Okay? So we got our energy. Now we're ready to find the wavelength, which is the right side of this equation. Remember, energy is our bridge. We solved energy. Now we can solve the right side. The left side was h times v. We solved it. We put that in the middle. Now that we have a number to work with, which is 6.288 times 10 to the minus 26. Put that in the middle here. And we could solve for the upside down y, the lambda, called wavelength. All right? So I've got energy equals h times c over lambda. I want lambda, which is wavelength. We got that from the equation. But remember, I got to get the wavelength on top. It's on the bottom right now underneath. So multiply both sides by the wavelength, by lambda, the wavelength. Multiply both sides by the wavelength, and it'll cross out. Multiply the left and the right times lambda. All right, you follow me? Okay, now it'll cancel out. These two will cancel. Let me just do that. Cancel them out. And over here, I got energy times, I got wavelength lambda times energy. So I want to get lambda alone, right? Wavelength is lambda. I want to get wavelength alone, the wavelength. So I can divide both sides by what? By energy. So divide this side by energy. Let me make a line first here. Divide this side by energy. Divide that side by energy. Right? And it cancels out here. Okay. I misspelled that, didn't I? Energy. Let me just type it over. Energy. So it's going to cancel out on the left here. So let me just cancel it out now. Cancel on top two because it crossed out. Get rid of the multiply. And I'm left with this equation. Lambda equal wavelength, which is lambda. Okay, this is wavelength. On the left here, this upside down y equals hc over energy. And the energy we solve for here, I'm going to make it all red now, okay? 6.288 times 10 to the minus 26. So here's where kids also make the same mistake. What do they do wrong? Same thing I said about the first part of the problem. Just separate out the exponents. 10 to the minus 34, 10 times 10 to the 8th, and I got underneath it 10 to the minus 26. So write in the numbers first on your paper. Do not start typing on your calculator. Don't do it. So what is it? So h times c over the energy. H is 6.626 times 10 to the minus 34. C is the speed of light, 3 times 10 to the 8th. And then underneath I have divided by the energy, which from the previous part is 6.288 times 10 to the minus 26. Some of you may want to leave it at 628 point, but just put everything in scientific notation. Okay, so we got on the bottom 6.288 times 10 to the minus 26. But don't solve it yet. Separate out the numbers with exponents. The 10 to the base 10 exponent values. I got 10 to the minus 34 here in blue. I got a black 10 to the 8th here, and I got a 10 to the minus 26 here. So pull those all out. All right. Just write in your paper up top now. Start up top. 10 to the what? I'm combining all the exponents now. All same base 10. I can combine all the exponents. So I got a minus 34 right here. 10 to the minus 34 plus an 8, right? Because I'm combining these numbers. It's minus 34 plus 8. You understand that? Now the tricky part is underneath I have a minus 26. So in the same exponent equation, okay, I have what? I have minus 34 plus 8, and then minus a minus 26. There are two negatives there. Don't get that wrong. When you divide by an exponent, you got to subtract. So 10 to the minus 34 plus 8 minus a minus 26. So what is a minus? A plus. So look at this. Minus 34 plus 8 is minus 26. Okay, minus 26. So the exponent's minus 26 plus 26 is what? 0. 10 to the 0, which is anything to the power of 0 is 1. So just times 1. So the exponent, I haven't used my calculator yet. Don't use your calculator. I have 10 to the 0 for the exponents. Now I go to the decimal numbers. You just do 6.626 times 3 What do you get? I'll wait. Type it in your calculator. 6.626 times 3. What do you get? 19.878 on top, right? I'll make that, I don't know. I'll make it bluish green. Get rid of the 3. I already used it up. Okay, so 3 times 6.626. I hope you got 19.878 in your calculator. Now I'm going to divide that by the other decimal, 6.288. So what is 19.878 divided by 6.288? 3.16. So I get 3.1, oh, it's right here, 6 times 10 to the 0, which is just 3.16. Anything to the power, any exponent of 0 makes it just automatically 1. So if this, if this were, I don't know, 500 to the 0, it would be 1. Anything to the power of 0 is 1. So the answer is just 3.16. What are the units of wavelength? Meters. That's how you do that.